So as I was saying, you could also do it as it's just your normal hyperbola, shift it to the left one. So your asymptote that would have been here would now move to -1 over here. So there's a few ways of seeing this. The answer is A. Any questions, actually? Use the following graph to answer these questions. A relation has been graphed below. Okay. What is the domain and range of this relation? Well, what does the domain look like? Domain looks like, can it be anything before 1? Well, looks like it, because it's going this way, and at 1, this also works here. So everything to the left at 1 works, and everything to the right also works because of this one here. So my domain is already going to be what? All real x. Yes, which is -infinity to infinity. So it's not C and it's not D. It's A or B. -infinity all the way to infinity. Range. Can my y value be anything? Well, it looks like it can be anything above 1, right? All of these numbers work. It can be anything below -1, but it can't be anything in here. This doesn't work. There's no y values there. So that means everything above 1, not including 1, everything before 1, before -1, including 1. So let's have a look. Everything up to -1, including -1, and not including 1, and all the way to infinity. The answer is A. So another way to see this is y is less than or equal to -1. This is y is bigger than 1. Y is less than or equal to -1. Y is bigger than 1. Does that make sense? Anyone at home have any questions? Y is bigger than 1. Y is less than or equal to -1. No? Okay. Question 6. Very straightforward. I don't think anyone really got this one wrong. 3 √2 minus √2 √5 is √10. Easy. Question 7. Completely factorize the following expressions. Okay. There's 4 terms. When there are 4 terms, you do grouping in pairs. Factorize your x out, x plus 2. Factorize your y out, x plus 2. Then when you've got the pair, that should have been x plus y and x plus 2. Anyone have any questions there? No? Okay, let's do another one. 2x squared take away 3x minus 9. You've got to factorize. The way I taught factorizing of trinomials was the cross method. You've learned it the PSF method or any other method, that's up to you. So 2x and x, 2 numbers that multiply to get you 9. That would be 3 and 3. And then would 6, 2 times 3, 6. Would 6 and 3 ever get you the middle term, which is 3? Yes, it would. If I did -6 plus 3. -6 plus 3 would give you -3. 3 times -3 is -9. 2x times x is 2x squared. I'm done. The answer is 2x plus 3, x take away 3. Okay. Again, any questions? Write down the equation of a circle with center 2 and -4 and radius of 7 units. Someone want to give this one a shot? Write down the equation of a circle. Squared, Ethan? You're going to say squared plus? You are correct. Equals? Well done, Ethan. That's fantastic. That is a circle. X minus 2 squared plus y plus 4 squared equals 7 squared, which is 49. Amazing. Well done. So the general formula for a circle is this. X minus h squared, y minus k squared equals r squared, where h and k are the are the center, sorry. Yeah, x and y. Solve the following equations. Okay, this was poorly done. So this is what some students did. Yeah, no, not allowed. You missed a solution. What's the golden rule with solving quadratic equations? What's the golden rule? Has to equal to something.
Has to
Zero.
equal 0.
Yeah, thank you. Has to equal to 0. Oh,
I did.
shit. Yeah, I heard that.
I did what you did, but then also I added a 0 after that.
Yeah, I know. You can't do it like that, though. It's got to be done like this. You got to write x squared take away 9x equals 0. Then you phase your x out. And then you got to say x is 0 and x is 9. You can't cross it out and then go, oh yeah, x equals 0 as well. It's not allowed. We can't actually award you full marks because you haven't factorized. Just be careful. That's the way. It's got to equal to 0. At least now you remembered it. You said, oh crap, that's it. So remember, equals 0. Doesn't matter. All right, good work. These ones. This was actually pretty well done for a lot of you. So that means we've really understood absolute values. So what do? We write 2x minus 1 equals 5, and then 2x minus 1 equals -5. 2x equals 6, x equals 3, 2x equals -4, x equals -2. Anyone have any questions for me on that? Okay. Next one. Write as a single fraction with positive indices. You know it's going to come up, something like that. Recall a to the negative x is the same as 1 on a to the positive x. So that's the general formula for your negative indices. So that means the first one, the 4 is not attached to the -2. So you leave the 4 on the top over m squared plus the 4 and the m are attached to the -2. We bring it all down. Next line, 4 on m squared plus 1 on 16 m squared. And again, can someone tell me what my common denominator is from these two?
16
m squared. That's
16
the one.
m squared.
16 m squared. You can't have just m squared because where's your 16? How is that common? It's got to be 16 m squared. Then you ask yourself, what's missing from this one and this denominator pretty much. So from m squared and 16 m squared, you're missing the 16. So you times the top one by 16. 16 m squared and 16 m squared, you're missing just nothing, so plus 1. 4 times 16 should be 64. Yep. 64 plus 1, 65 on 16 m squared, you're done. It's a single fraction with positive indices. two functions are defined as f of x and g of x. Find in its simplest form the value of g of 4. Oh, very easy, very well done. G of 4, you're just going to sub it into g of x. So it'll look like this. Done. That gives you negative 16 plus 4, negative 12. Nice and simple. If I ask you what is f of negative 2, it just means sub in negative 2 into your x value. So it would have looked like this, which would have given you, in that case, 12, for example. Easy. This one says the value of x for which f of x is negative 3. That means this f of x and this f of x becomes now negative 3. So it'll look like this. Negative 3 equals 6 take away 3x. Instead of f of x equal to 6 take away 3x. Because what does f of x equal to now? Negative 3. Why did you say 0? F of x equals negative 3. So you replace that f for negative 3. It's like me saying this to you. Sam equals 10 take away 2x. And I'll tell you, Sam is 15. Well, isn't that the same as you saying, oh yeah, 15 equals 10 take away 2x? That's exactly what you've done. Instead of being Sam, it just says f of x. So don't let the f of x confuse you. Same logic. Just do that for now. All right. And then obviously it's very easy to solve from here. Negative 3, take away 6, negative 9. Delta, you need help? No. X equals 3.
Sam,
Yes.
for a g of 4,
Yes.
isn't negative 4 squared positive 16?
Good point. But doesn't this one actually say negative x squared?
Oh, okay.
Wait, are you sure you get the difference?
Yeah, yeah.
Because this one actually is telling you whatever the x is, you're going to square it, and then you're going to put a negative in front of it.
Right, okay.
Whereas the ones you're used to, like let's call it for our quadratic formula, you know how it's like this. If I told you b is negative 3, this would be wrong. Because b should have been negative 3, so it would have looked like this squared. Because it's b squared. Whereas this one says it's actually negative and then x squared.
Right, okay.
Right, yeah. Yeah, that was your mistake, I think.
Yeah.
It's funny, for your one, when I was marking it, it wasn't actually your math that was wrong. It was just silly mistakes like that, and then there's another one as well coming up that I remember from your paper.
Yeah.
And that's why I said I just think we should do it again to show you guys, like, sometimes it's not just your math either, it's those silly mistakes. And the only way you're going to get rid of those silly mistakes is by doing a lot more exams like this for yourselves. Even when you're at home, when I was at your age, I used to just put aside 20 minutes, 25 minutes and just get a whole bunch of questions and go, let's just do a sample exam for myself. And that's it. That was the best form of practice you could do. Mimic an exam, pretty much, is what I used to call it. G of f of x. Okay, what does that mean? Well, let's write them down here quickly. F of x was, f of x was 6 take away 3x. That's just saying for which this, like that's it. Part B is done, you're up to part C. F of x was 6 take away 3x. G of x was negative x squared plus x. Okay, again, just recall, what does this mean? G of 5. What would you do? Sub 5. Good. So we get it. What would you say then to g of f of x? 5 into f of it. There's no 5 now.
Sub f of x into the g formula.
That's perfect. Again, see how you just said 5 and you got it so easy? Why do you change it when it's a little bit harder? Don't do that. Sub, that was perfect. Sub f of x into g. That's perfect. Simple. Exactly like if I had given you g of 5. You said subbing 5 into g. Well, doesn't matter g of anything. Yes, sub f of x. So it's going to look like this. G. What is f of x anyways? F of x is 6 take away 3x. Sub this into g. It will look like this. Can you see that happening, Ethan? Negative x. But instead of the x, it's 6 take away 3x. Why? Because x is now f of x. And then again, plus this 6 take away 3x again, instead of the x. So wherever you see x, it gets replaced for f of x. But what does f of x equal to? 6 take away 3x. Okay. Of, g of. Then expand, negative, bracket, 6 squared. 6 squared is 36 minus 18, so 36x plus 9x squared. That's how you expand using perfect squares. Plus 6 take away 3x, then you bring the negative in. And then we finally simplify. Minus 36 plus 6 is negative 30. 36 take away 3 is positive 33x minus 9x squared. And that would be 4 marks. You don't need to you don't need to factorize. Why would you factorize? If the question doesn't tell you to factorize, why are you doing more work now? Good point. You can do it, but why are you doing it? You're doing more work for nothing. So no, you shouldn't factorize. Okay, good. This one, by those who got to this, I think only one person got it right. And that person, I won't say who it was and who wasn't, but that person just used their brackets correctly. So I think those who attempted it, all of them realized what it was, which is a difference of 2 squares. But there was only one person that actually was able to get the brackets out properly. So to the others, when you're about to see this, I think it's a lesson learnt again. Silly mistake. Please be careful. You've got to use your brackets properly. Okay, this is a difference of 2 squares. Why? Because like you can see, they're exactly the same, except that's a minus and that's a plus. So difference of 2 squares should expand to essentially something like this. The first one squared minus the second one squared. That's your difference of 2 squares, right? So in this case, it's going to look like this. Square root of x plus y squared minus square root of y take away x squared. So a squared minus b squared. Easy? When you realize the difference of 2 squares, a squared minus b squared. Then you cross out. That was also done pretty well, and then here's the mistake. This is wrong. Don't write that. You got to still have brackets in there. X plus y minus bracket y take away x. Next line, x plus y take away y plus x. Y and y cancels out. The answer is 2x. I think some of you got 0. For those who got 0, you know the mistake you did now. use your brackets. And I think I even specifically remember teaching your class, I said it's probably better for you guys to use more brackets than to use less brackets. And I said, more than anything, if you see a negative, you definitely should use brackets. If you see a positive, I guess it's not going to hurt you too much. But if you see a negative, you better be using brackets for expanding. Okay, there's that one. Any questions? No. All right. Two functions are defined as this and this. And just so you guys know, these are called, obviously, parabolas. And these are called absolute values, absolute value functions. By completing the square, show f of x is this. Okay. I guess the way we've always done completing the square has been like this. I made it equal to 0 if there's no other numbers, so you make it equal to 0. Constants are going to go to the right-hand side. There it is. Then we wrote bracket, bracket. Then we would write squared. Then we would write x. We would half the -4. Then we would have squared it on the other side. Let's do that all one more time. So completing the square means it should be a perfect square. So we already know it's going to look like this. Constants on the right-hand side, always. X always here. Half the -4 goes in there. Square that term, goes in here. Always a plus sign. -5 plus 4 is -1. Bring it back to the left-hand side, and you will prove the question that they had equals f of x. Easy. That's the way I do my completing the square. I think at your schools they teach you to halve it and square it all in the same line and whatnot. It's just not my technique. I haven't seen it be very successful. Okay, turn to the next page, sketch both f of x and g of x on the same number plane, clearly showing any points of intersections. So we've got x minus 2 squared plus 1, and go here, f of x equals x minus 2 squared plus 1, and g of x equals negative absolute value of x plus 5, was it? Yep, all right. So, x minus 2 squared. Ethan, parabola has moved to the left or to the right? Correct, opposite direction. So minus 2, we're going to go to the right 2. We'll say that's 1. We're counting threes. 1, 2, 3, that's 1. 1, 2, 3, that's 2. Then we shift it up by 1. So 1, 2, 3, that could be 1. And there's your parabola. Any questions from anyone? Okay. How do we draw g of x? Well, it's an absolute value. What shape is an absolute value? V. They're V-shaped. It's negative V. So already it should look like this. And then plus 5. Then we go up by 5. So 1, 2, yeah, 2, 3, 4, 5. How many points of intersections do you think it's going to have? Using your graph, find the values. Oh no, sorry, I missed it. Don't worry, wait, I'll go back for a second. Any questions about what I've done with the first two, with these graphs? Is there a reason why one's longer than the other? No, no reason. It doesn't really matter, right? Because there's arrowheads at the end. So I could have actually drawn this even up to like that. This goes on for ever. This goes on for ever as well. Yep. That was just me. Sorry. There. Using your graph, find the value or values of x for which this happens. Now, this is really weird. It's greater than 0. Okay, let's just pause for a second again. Write down what f of x was and g of x was, because can you see it's not expanded? Sorry, it is expanded, so I'm not going to use this version. I would technically use the original version. What was the original? X squared take away 4x plus 5. X squared take away 4x plus 5, and g of x was negative absolute value of x plus 5. Can anyone see what I'm trying to say with C? Anyone see a link between f of x and g of x and this expression?
I see one, but I don't know how to explain it.
Say it. Say what you see. In any way that you can.
Like x squared minus 4x plus 5, and like what's it called? Like make them equal, and then you minus 5, and then you bring x over to one's.
Yeah, you're actually saying it correct. No, you're right. You're absolutely correct. So if I made f of x equal to g of x, four x plus 5 equal negative absolute value of x plus 5. Then when I bring everything to one side, the 5's would cancel out. Wouldn't I end up with x squared take away 4x plus absolute value of x is equal to 0? Is that what you meant?
Yes, Sam.
Yeah, that's perfect. Very close. Now, this is equals. This is greater than. So what are you going to change the first one to? Instead of f of x equal to g of x. What are you going to change the equal sign to? Greater than. You want to find when the function, this function here, f of x, is bigger than g of x. When would your black curve be bigger than your blue curve? When would your black curve be bigger than your blue curve? Now, I don't know if I've drawn it exactly precise, but my black curve would be bigger than my blue curve at 2 points. Black bigger than. Oh no, I haven't drawn this very well. I just should have actually drawn this a little bit more exact. But that's okay. I'll give you the answer for the graph I've drawn. Then I'll actually show you the proper, because I know this black curve should have actually gone through 5. I made it specifically to go through 5. So my y-intercept should have been like that. And that's why I said here, clearly showing any points of intersection, because it was very important for the next bit. But that's okay. I stuffed up my own question. Go back. If it was this one here, where is the black curve higher than the blue curve? Well, the blue curve, let's say anything after this point here. Right? Anything after that point, the black curve will always be higher than the blue curve. Isn't it? No, sorry. Right here. Anything after that point, the black curve is higher than the blue curve. The black curve is higher than the blue curve. Do you see that? So any x value less than this. And same thing with this one. This right now the blue curve is higher than the black curve, but once they meet, and then the blue curve continues, any x value greater than this. The black curve is higher than the blue curve. So if you had it said x is greater than 2, if you had drawn it like me, and x is less than -1, I would have given you full marks. But it should have been that x equals 0, because this black curve should have actually crossed over right out the 5. So the answer should have been x is less than 0 and x is greater than 2. X is less than 0, x is greater than 2. That's when the black curve, f of x, will be bigger than g of x. So I'm going to do quickly another one, just to show you, and then I'll scroll up. So here's two random curves. Here's a parabola. Just so you can get the concept through your head. And here's a hyperbola. Right? And we're going to call the parabola x squared. We're going to call the hyperbola 3 on x. And the question I'm going to ask is obviously very basic. When would f of x be bigger than g of x? When would the black curve be bigger than the g of x? And just for argument's sake, we'll find the point of intersection, which is at 2, 2. It's not, but we'll just say that. All right, go. When would the black curve be bigger than the g? Does anyone want to take a guess? Just so you can see if you can understand this. When does it look like the black is bigger than the blue? Anyone? Oh, yep. Hold on. Yep, go ahead.
When x is greater than 2.
I agree. The black curve is definitely bigger than the blue curve for anything greater than 2. And
I'm not sure of the next one.
come on, where else is the black curve? Okay, here it doesn't look like it.
Greater than 0?
You mean less than?
Less than 0.
Less than 0. This bit here, the blue curve's higher. Right, up here somewhere, the blue curve's higher than the black. So blue is higher than black, blue is higher than black, blue is higher than black. Here, black is higher than blue. Black is always, in fact, higher than blue, no matter what, on anything less than 0. So that would be a case like this. If the question said, at what points would x squared be bigger than 3 on x? X squared being greater than 3 on x. That's all they're trying to say. Where is the parabola higher than the hyperbola? Another way could be, they could make it look weird. There, x squared take away 3 on x is greater than 0. But they all still mean the same thing. All right, I'll go up if you need a copy, anything, or if you've got any questions for that one then. If not, we'll do another test. Anyone have any questions? Then? All right.